There are a lot of ways to solve systems of equations, not just by the elimination method. Actually, some methods which use rectangular arrangements of numbers called matrices. And as we'll see shortly, you can also, at least theoretically, solve a system by graphing, at least a small system of equations. Anyway, but the elimination method in the small case where you have 2 or 3 letters is by far probably the easiest and the fastest, certainly to learn. But there's a very related method known as the substitution method, which I think is quite valuable. And I think you'll see as we apply what you're learning right now to solving some word problems, that some word problems lend themselves very well to substitution. All right, well, let's look at this problem. It's organized a little differently. Solve x equals to 3y minus 10 and 3x plus 5y equals to 26. Well, what's convenient about this arrangement, instead of having all the x's and y's on one side in this equation is actually solved for x. So we have a replacement for x. Another name for x is 3y minus 10. So what I'm going to do is take this expression for x and replace it in the second equation. And so this is called the method of substitution. So let's see what happens. I've got 3 times 3y minus 10 plus 5y equals to 26. Notice that I use parentheses here. And people who are too lazy or careless to use parentheses very often make mistakes with negative signs and distribution errors. And so don't be lazy about that stuff or careless. So replacing 3 with x, with 3y minus 10, written in parentheses, because this 3 multiplies that entire quantity. And so I'm going to now distribute the 3 through here, and it gives us 9y minus 30 plus 5y equals to 26. And we'll clean this up a little bit. These terms combine, so that's 14y minus 30 equals to 26. But look what happened here. By substituting x in for y into one of the equations, that allowed us to actually eliminate x and then solve for y. And so now I can quickly get a number for y. I'm going to add 30 to both sides. And we have 14y equals to 56. Divide by 14. And 14 goes into 56 exactly 4 times. So y equals to 4. Now, what would you do with that? Well, we found that we can take the first number we get and substitute it into either equation. Would I put y equal to 4 into the second equation? We can, but it would make much more sense, wouldn't it, to use the first equation? Because the first equation has already been solved for x. So it would be faster if I replace y with 4 into the first equation. X equals to 3 times 4 minus 10. X would be 12 minus 10, or 2. So I have an answer. 2 comma 4 is what I believe is the solution to this problem. All right, well, substitution, you'll find, under the right circumstances, is actually faster than the elimination method. To eliminate here, it would probably would need to rearrange the first equation so that x and y are on the same side. But substituting was actually fairly quick. All right, well, let's go ahead and check this. And I'll make room. All right, so to check, we're going to have, let's see, x is 2 and y is 4. So in the first equation, 2 equals to 3 times 4 minus 10. 2 equals to 12 minus 10. That checks out. In the second equation, I've got 3 times 2 plus 5 times 4 should be 26. Here I have 6 plus 20 equals 26, and that also is true. So again, we can check this out, and if your answer fits both equations simultaneously, then you can be pretty confident you got the right answer. So that's the substitution method.